Welcome to this explainer. Today, we're diving into Chapter 3 in English, specifically looking at mathematical operations on whole numbers. Listen, we are going to totally strip away the textbook intimidation right now and just build up your everyday math toolkit. Because whether you're managing a personal budget or running a massive factory, these concepts are quite literally the invisible gears that keep the real world turning.
Here is what is on our agenda today. 1. Meet the whole numbers. 2. Addition and subtraction realities. 3. Mastering the multiplication shortcut. 4. The power of 10. And 5. Estimating in the real world.
Section 1. Meet the whole numbers.
Okay, so you hear the term whole numbers thrown around a lot. But what exactly does it mean? Well, whenever we talk about whole numbers, we simply mean our basic everyday counting numbers. We start right at 0, and then it's 1, 2, 3, 4, and so on, upwards to infinity. The absolute most important thing to remember here is that there are no fractions, no tricky decimals, and no missing pieces. Just perfectly clean, complete numbers.
Section 2. Addition and subtraction realities.
Now that we actually know our numbers, let's grab our next tool. We're going to act a bit like detectives here and solve some real-world mysteries. Imagine you were at a massive gathering. You've been told there are 300 people there in total, and someone has counted exactly 192 males. So the burning question is, how many females were there? Think about it. Can you use subtraction to figure out this missing puzzle piece?
The logic here is just incredibly satisfying. Step 1, you start with your total whole number, which is the gathering of 300 people. Step 2, you simply subtract the part you already know, the 192 males. And step 3, boom, you instantly reveal the remaining 108 females. By simply taking a whole number away from a larger whole number, you effortlessly reveal the hidden answer. It is really that simple.
Let's move on and see how this actually builds into personal finance. Take Hishan's budget breakdown, for example. He receives 325 rupees from his father and 430 rupees from his mother. But then, he goes out and buys a pair of slippers for 149 rupees and a book for 225. How do we figure out what's left in his wallet? It's just a combination of our tools. You add up his total income, then subtract those total expenses, and you instantly find out exactly what cash he has left over. Honestly, it's just practical, everyday empowerment. And what's really cool is how this brilliantly illustrates that these exact same rules scale up to massive industries. Check out this bar chart comparing 145 cars in 2013 and 2,325 cars in 2014. Big corporate factories use the exact same basic subtraction to see how much their production grew from one year to the next. The rules of whole numbers literally do not change no matter how ridiculously big the numbers get.
Section 3. Mastering the multiplication shortcut.
So you've totally got addition and subtraction down. But what happens when you need to count things fast? Notice the contrast here. Say you have 3 groups of 5 guavas. On the left side, you could definitely just use addition and count them up group by group. 5 plus 5 plus 5 equals 15. It works, for sure, but it's kind of slow. On the right side, we see the multiplication shortcut. 3 groups of 5 equals 15. Multiplication is really just repeated addition, but completely sped up. It is the ultimate math shortcut.
Mastering basic products like 3 times 4, 7 times 3, and 9 times 6 is literally like upgrading your everyday toolkit to a power tool. When you instantly just know these facts, you stop getting bogged down in the slow mechanics of counting and start absolutely flying through problems. Oh, and by the way, never forget the golden rule. Any whole number multiplied by 0, like 8 times 0, is always 0.
Section 4. The power of 10.
Now we're really rolling. There is this amazing visual trick you can use when you're dealing with tens, hundreds, and thousands. Look at the pattern here in the table. 2 times 10 means 2 tens, which is 20. 2 times 100 is 2 hundreds, so 200. And 2 times 1,000 is 2 thousands, giving us 2,000. Do you see the magic there? You just look at how the zeros physically transfer over. You take the base number, count the zeros in your multiplier, and just slap them onto the end. 2 times 1,000 instantly and magically becomes 2,000.
And the absolute best part is that this works beautifully for bigger numbers too. Look at 12 times 10. That's just 12 tens, or 12 tens, which is 10 tens plus 2 tens. Following our awesome rule, you literally just take the number 12, add the single 0 from the 10, and it instantly gives you 120.
Once you see this pattern, mental math with big numbers suddenly becomes entirely unintimidating.
Section 5. Estimating in the real world.
Finally, let's talk about estimating. Let's be real, you rarely have the time to count everything perfectly. Sometimes you just need a highly educated guess. Our source material brings up this beautiful historical 1854 quote from Native American Chief Seattle. It's a dense, moving text about how every part of the earth is sacred to his people. But here's the mathematical challenge for you. If I asked you how many words are in this entire text, how would you figure it out without painfully counting every single word one by one?
Well, you can use a brilliant shortcut. Step 1. Just pick any 3 lines and count the number of words in those specific lines. Step 2. Find the average number of words per line based on that tiny sample. Step 3. Count the total number of lines in the paragraph and multiply your average by that total. By combining basic counting, division for the average, and multiplication, you can accurately estimate the size of the whole entire thing in just a fraction of the time.
But estimating actually leaves us with a totally fascinating philosophical math question from the text. A student named Jihan mentions that when an estimate is made, the answer actually depends on the person who is making the estimate. I want to leave you with this final real-world mystery to chew on. Since we all might pick entirely different lines in that speech to average out, will 2 people ever get the exact same answer when estimating? What do you think? Thank you so much for joining me in this explainer, and keep looking for the math in the world around you.